Welcome, learners. Here with me today, that is in this video, is a new topic that we are to be introduced up with, and this is coordinate geometry. Right, having done several topics, like previously, we are looking at the similarity. Now, in here, without wasting time, as per that's the title. We're talking of coordinate geometry. So you are always there from it, and you can predict that what it is all about this. That's what is it that we're going to discuss then in this topic. Right. So the coordinate geometry is all about the coordinate system. It means the whole discussion that we have here will be based on the Cartesian plane, where we shall have the pair, ordered pair of values, right, of a particular point, and we'll be going to interacting with them. So all in all is about the Cartesian plane when we shall have the coordinates right. Now, what is it that is we are going to do exactly in the Cartesian plane, such that we have to at least focus on the coordinates in the Cartesian plane. Right, so here on the Cartesian plane, we are specifically going to study a line. Right, so now when I talk of a line segment, in this case, we have to consider a situation whereby a line has to connect to 2 points. At least, of course, we know that the line is just a connected of several points. Right, so like for example, if this body is just like a plane face, whereby now I may draw a y-axis and again the x-axis like this, then this plane now changes automatically into what we call the Cartesian plane. So that if I can incorporate in a scale of some kind, again the x and y axis like 1, 2, 3, here -1, -2, 1, 2, 3, and here -1, here -2, it means everywhere I fix a point, that point is going to be described by 2 values. Right, one value is the value that we're going to check on the x-axis, another one we're going to check on the y-axis. Such type of values describing a particular point, like in this case, if I've got a point here, right, I'll be able to say this point, which is point D, is found at the position where x is 3 and y is also what? A 3. Right, so here we're looking at this point found at the position of x, y, like that. So here x is 3, and again it happens again y is 3. So these 2 values are known as the coordinates. So this is the x coordinate, this is the y coordinate. Right, so you may also have another point somewhere, like say for example, I can have this point here. Look at that one. This can be point x. It's also found that this one is described by what? 2 values. And one value is the value on the x, another value on the y-axis. So if I'm to capture these 2 values, it means x is found at x is 1 and the y is 2. So these are the coordinates. Now, our discussion will be there based on the what is it about when I connect any 2 points like D and X. So if I connect D and X, definitely what I'll have is just like what? A straight line segment. So our discussion here will be solely on the line segment that is drawn on the Cartesian plane. While in mind, we are considering that the point, the line itself has got points, the points of which are described by what? The coordinates. So this all that is what we need to know, and that's our direction. Main emphasis is more like describing up the characteristics of the what? Of the line segment drawn in the what? Cartesian plane. Right. As such, we are going to be guided by the following objectives in order to meet everything that we need to know in the discussion about the coordinate geometry. Right, so all about it is just the study of a line segment in different forms, and this line is drawn in the Cartesian plane. Right, so can we now take note of the following objectives that we're going to meet the whole discussion in this topic. Right. So that at the very end, when I say I've concluded the topic, what you need to do is just a matter of asking yourself, have these objectives been reached. And what about these other objectives? So we'll be going by that. If you have really seen that everything has been reached, it means you are successful. You have really captured everything about this topic. And that will be 100% better. Right, so the first thing that we need to do here, right? Normally, you as a student, you need to know at the very end of the topic, you have to know how you can calculate the gradient of a line segment that is drawn in the Cartesian plane. Then after relating the gradient of the line to a tangent of an angle. You know, I've been discussing about the trigonometry one somewhere where we're introduced into the ratios, sine, cosine, and tangent. So here, somehow, if we work out the gradient of the line, that one is somehow related to what? Tangent of a particular angle that is formed in a particular triangle side. So you see what we're going to have in that manner. Distance between 2 points needs also to be calculated, like I connected 2 points there to form a line segment. So what is the distance between those 2 points? Thereafter, we need also to know how we can calculate the equation of a straight line. Just give me a guide. Every line that we're going to draw in the Cartesian plane must have an equation. So it's more like no straight line shall not have an equation. Every line should have an equation. Right, so how do we calculate the equation of any line segment? Then after, we're also going to consider issues about the parallel lines. Right, given one line is parallel to the other, while one line's equation is known, we should be in the position to calculate the equation of the other line, having known that that line is parallel to the other one. So such type of discussion will be there again. We need to know about them. Right, very lastly, we have two more objectives. Of course, there will be several things that we'll be discussing, but these are just like the skeletal parts that will give us a guide so that the whole topic, that is the issues about the straight line drawn in the Cartesian plane, has to be well understood. Right. Two more bullets. Midpoint of the line segment. You draw the line on the Cartesian plane. What is the midpoint of that particular line? Will you be able to determine the midpoint? And then describe it by two values. That's the coordinates. What is the value of x, what is the value of y at the mid part of the line? Then finally, we have the practice somewhere where we have got at least further questions that we need to practice so that we can master everything that we have learned. Right, so these are just like the guides of which we will be carrying us through until the end of our discussion in this topic. Right, so let me now remove them out, and you have to be able to remember them each time we discuss, that when I finish the video, you shall be able to say, this video was all about this objective. Right, now, firstly, what is it that we need to know? According to the objectives, the first thing is the gradient of a line segment. Right. You need to know how to calculate the gradient of the line segment. But first, you have to know the meaning of the gradient. Because you cannot just say, this is the way we do such maths about memorization. We don't want that. What is gradient? Right. If you talk of a gradient, as is earlier indicated, our discussion will be on this chart here. This is the board we have. This one, as you can see it, is a good example of the Cartesian plane. Suppose I have the this one as one of the major talk of the vertical lines. The line, you see that this one is just equal plane face, which has got several lines. Some are horizontal, some are vertical. Right? The horizontal lines, by what we learned in the past to go from one, are described as what? The y-axis. So we have just identified one as one of the main y-axis, representing the rest, which are just the vertical lines. So this one is the y-axis, and the horizontal lines on one way or another, you are able to define them as what? X-axis. So here I've got this line here. I described it as the x-axis, and there it is there representing all other lines of the same nature. So now here, what we are looking at is just to know what a gradient is of a straight line with respect to the Cartesian plane. When we talk of a gradient, first of all, we need to understand that if I would draw a line in here, we have to expect that, say, a line that is going to be drawn here will always have a slope. Right. I can draw it this way, there will be a slope. I draw that way, it will be a slope. Say, for example, I have got a line connecting this point here, that is point A and point H, like that. 2 points there. You'll be able to see that if I join this line like this, that line will always have a slope. But now, that slope is determined with respect to the what? A horizontal line. Without the horizontal line, or horizontal surface, you cannot describe the slope of something. So like if I say here there's a slope, I have to consider the horizontal line, which is this one here. Then I would say that this line AH has got a slope. Right, so we talk of the slope here is AH. Okay, the slope of AH goes something like that. Right, I might also have another line in the same vein with respect to the same horizontal line here. You find that this line can connect this point there and this other point here. So if I were to draw this line will be like this, right? If this is N, this is T. But two lines, AH and NT, are all drawn with respect to the horizontal line, which is this one here. And we call this one as the x-axis. Right, but now if you can look at the nature of the slopes in this case, this slope and this slope, the slope for this line and the slope for that line, if we had say, maybe if we go to consider them like maybe there are hills, there are hills, you'll be able to see that at least this slope is much steeper as compared to this one here. So now, in this case, if we were to consider issue about that, it's not all that making sense in mathematics to say one line is steeper as compared to the other. No, that does not make sense. But we need at least to measure by values. As we always say, if one has got more money, somebody has got less money, you'll be able to ask, say, by how much? You need at least to know the values. So in maths, we describe everything by a value. So here we have got a slope for line Tn, a slope for line T of what? AH. And we see that AH is steeper than what? NT. So it means in this case, we need at least to measure the slope line. So the measure of a slope of a line segment, that one is what is defined as what? Gradient. So what is the measure of this line? What is the measure of the slope of this line? What is the measure of the slope of that line? So we're going to practice that, how we can measure the slope of a particular line. So the value you use, that is known as what? The gradient. Right, so I think you understand what the gradient is. So simply, I may just write it for your own interest sake to say gradient is simply in the measure of a slope of a line, what? Segment. Simple as that. Right, so now let's get into business. How do we measure the slope of the line? Now, for you to know how to measure the slope of the line, like the one I've drawn here on this Cartesian plane, right, let me produce another one now, since I've already defined it and you know what it is about it, right? So I have to draw another one that is much bigger. But now before that, allow me first of all to fix in the scale for the y-axis and x-axis, because that is what we all know each time we're discussing issues about the what? Cartesian plane. So how do we talk about the coordinates in this case if we don't have that scale? Right, so here, let me have that for any two distances, I'll have, like, say, this one, let it be talk of the 1, 2, then 3, then here 4. And here it means now we have got -1, -2, then what? -3. Right, so here I'm using the, if these are 2 centimeters, it means if these distances are at 1 unit, it means I'm using 2 units representing 1 unit as the scale. Right, so what I have on the y-axis, I also do the same. Let this one be talk of 1, this one be 2, this one be 3, this one be 4. So it means on the lower side here of a 0, we have -1, -2, -3, then -4. Right. So what is there? It's like, for example, I draw a line that is connecting this position here. Right. This is line from T connected to position, talk over that position here. Talk of what? F. Right. So I'll join the two points here. Line from T to F, it'll be like this one. Right. So this is a line TF. Right. So as you can see, with respect to line, which is this one here, the x-axis, we can take this one here, the x-axis, because this is the starting point of that line. We'll be able to determine that the slope of this line is the one that goes up like that. So now we are there to find out what is the measure of this slope, and that's what is the gradient. So for us to calculate the value that represents this slope, we need to consider exactly what forms that slope. Right. You found that that slope is coming from 2 stories. Right. And these stories have something to do with what is their issues about the what? X and Y axis. Right. Like say for example, if I'm at position T here and I would like to go up to F here, right, what I'll do is I can move upwards like this. I go. As much as I'm going up this line, you find that I'm covering a distance along the what? X-axis like this. I'm going this way. If I'm at this position, it means I'm just like here. If I'm at that position, it means I'm here. If I'm at this position, it means I'm here. So it means that as far as I'm going up, it's just like I'm covering along the what? X-axis. Similarly, there's a change along the X-axis. Right. At the same time, as I'm going up like this one, it means just like I am moving upwards along the Y-axis. See, if I'm here, it's as good as I am where? I am here. If I am at this position here, at this position, it as means I'm rising. And the moment I'm here, it's just like I've left the 0 part, I am somewhere upwards. So as I am talking of this slope here, of this line, it is a slope that is formed due to the effect that is there as the change along the x-axis and the change along the y-axis. Because if the x-axis does not change here, there's no way that this line can exist. And there, it means what? A slope will just be 0. There's no slope there. So everything about this line has to do about the what happens along the what happens along the x-axis. That is the change along the x-axis and the change along the y-axis. Right. So here, if we're talking of the slope of the line with the gradient, we just take the ratio of the change in the y-axis and change in the what? X-axis. So you talk of a change in the y-axis to change in the x-axis that gives us the measure of the slope and call that one and the gradient. Right. Now, for example, if I'm to come up with that value, which is the gradient of talk over line T, that is F. You'll be able to see that if we change along, we talk of the change along the y-axis, talk of the change in y-axis to change, talk of the change in x-axis. This change is just coming up when you just talk of the differences. Simple as that. Of what is there. Right. Like say, for example, if I talk of here at T, I am at this position, the value of x here is negative what? 2. While y there is talk of what? Okay, the value of x here is negative 2, and the value of y there is 1. At this position here, you find that the value of talk of what x here is a 3, and the value of y there is what? Is a 4. Right. So it's just like from here up that, how much change do I have along the x-axis. And from here to that same position, what is the change that has taken place along the y-axis? So two ways how we can have that change is by doing this. One, to find that change, first of all, let's talk of the along the y-axis. Y-axis, this is the y-axis. You can just count how many units are there in between T and F. So if, like, for example, I'm talking of at T here, at this position, along the y-axis, this is the y-axis, is as good as you are here. Right. And now when I am at F, I'll be talking like at this position, along the y-axis there is as good as being there. So F, the one F, the F you see here is just being there. The T you see is just as good as being there. So if you talk of the differences or say the change between this position and that position, it's just amount of units that you can count in. So you talk of, in this case, you have got what? You talk of 1, 2. You know, this note is 1, We are already in the scale part. So it means you talk of the gap here from here up that it's 1 unit. Then here is another unit. This is another unit. So the difference is just like 1, 2, 3. So it means the change along the y-axis there is just a 3. What about the x? Right. At x is as good as I'm here. Being there is as good as you are here. Being here on the x-axis is as like you are here. But now, when you move, you find that if you are at F, at that position, along the x-axis is as good like you go down there, you are where? You are here. So if you are here at T, the starting point is as good as you are -2. At F is as good as you are what? At 3. So if you want to find the change from between T and F, you can just count the units. How many units are there? So say if you are here, you find that here, if you come from here up to -1, this is just a difference of 1 unit, another unit, another unit, another unit, another unit, until you are at what? At F. So if you count how many units are there, you talk of 1, 2, 3, 4, then 5. So it means here you have got 5 units. That's the change along the x-axis. Change along the y-axis. Right. So it means the gradient here is just like 3 to 5. That's what we say. It's not 3/5. You understand that this is just a ratio. Gradient is more like the ratio. So you talk of the changes along the x and along the y-axis. Right. Another way around, if you don't want to count the units as such, just try to find yourself, to ask yourself, to say what exactly that is there in between T and F by the coordinates. You'd really see that if we talk of the change along the y coordinates and also change along the x coordinates, you'll be able to do issues about the subtraction. It will give you the same values. So here is just a matter of subtracting the y coordinates and subtracting the what? The x coordinates. So here it will be like you talk of a y, this is the value of y at F here, and this is also the value of y. And this is the value of x here, this is also the value of x. So it means if you subtract the values of y, you have got a change along the y-axis. And if you talk of these, you subtract the values of x, it means you're coming up with the changes along the what? X-axis. So this will go something like this. Y here is 4. So 4 has to subtract a 1 like this. So you talk of changing y, instead of counting the units, you have got 4 minus 1, and then 2, changing x, that's just like delta x, this is delta y, talk of a change, right? So what you have here, you talk of the x is 3, you talk of 3, then minus what? You talk of minus a 2. At the end, what do we obtain here? You find that that are the same as what we have obtained earlier. So here we have got 4 minus 1, you get a 3. 3 minus 2, you get what? A 5. So this is the gradient, and that is the gradient, a measure. Right. So the measure has to be understood in this form of the ratio. You talk of 3 to 5, you talk of 3 to 5. Right. So to come up with the formula, maybe in general, you may be able to realize that what we have done here is simply like a situation whereby we go like, when I say 4 minus 1, it's just like I'm saying y minus y. According to this one here. When I talk of the 3 minus -2, it's just like I'm saying x subtracting another x. It means we have got 2 x's, we have got 2 y's. And that is true. If we have got 2 points, it means we have got 2 coordinates for y, we have got 2 coordinates for y, for x. So it means the gradient here has something to do about the change, and that the change is determined by what? differences with the y coordinates and the x coordinates. So in that case, I'll talk of the x2 should subtract x1. So let y2 subtract y1. So this is y2 subtracting y1. Then, if this is my y2, so we should expect again, since we're heading toward this way, there's no way that this now can be x2. So I still have to talk of this one, subtract this one. So it means that we have got x2 minus x1. So that's the way it goes. So in short, we talk of the gradient. In this case, it's just gradient is just equal to what we have along the change in ay and the change in x. So you can just have the gradient can be defined by this formula. Very simple formula and very brief. Change that's delta y to delta x. Delta y simply means this. Delta x simply means that. So you subtract, you have the gradient. Right. Now, let us now look at the relationship finally. That's very simple. Suppose I construct a triangle from point T here, heading towards this way, that's the line from T, and another line now from F there, heading downwards like this. I extend the line from F going downwards like that to any point. The two lines here are going to intersect at this position here. Light. And what we have there is just like a light angle. The lines will always intersect at what? Light angle, just 90 degrees, if I join. So if I'm to count the units from here up that, I found that this is what? 5 units. I'll count the units from here up that. I found that it is what? 3 what? Units. Look at that. So if I got the 3 units, this is just like a change in y. If I look at the 5 units, this is a change in what? In x. So by what we did in the trigonometry, you find that in a lighter triangle like that one, if somebody is given an angle like here, angle theta, you'll be able to appreciate that 3 is the opposite side to angle theta, and this 5 is adjacent side to what? Angle theta. So the moment you are working out the talk of the gradient of the line, that is talk of TF, that gradient is as good as the value of the tangent of a particular angle. So in this case, if I talk of, can you find the tangent of what? Like this one. Look at this one. Look at this. Look at this. Look at this. Look at this. We talk of the tan of theta. If you talk of what? Opposite divided by adjacent. And now somebody comes and say, gradient of talk of what? TF. You'll be able to see talk of the change in y and change in x. You still have the same what? Values are 3 over 5. So the relationship that we have here is just like if you talk of a tangent of a particular angle, that is just the same as what? Gradient of the straight line. So such relationships, at least we need also at least to be able to know and understand as the students. Right? Because you have to connect up the two topics like that. Yeah, I learned something about this. So what is it now? I'm meaning this. So some kind of analyzations are true in mathematics. Gradient of a particular line is the same as the tangent of the line. And that line always tends up to be like what? Hypotenuse side. So please discover this one and take note of that. As of now, thank you very much for being together. And in the next video, what we'll do, I'll give you just an example and then proceed with our discussions in the same issues above the coordinate geometry. Thank you.